Welcome everybody. Today's lesson is about cooling curve. How can I deal with cooling curve when we talk about cooling a process? It means we are decreasing the temperature. Okay, so if I want to decrease the temperature of a gas, okay, and decrease it furthermore and more, then the gas eventually will end up to be solid. How can I describe that? How can I explain that? So first of all, we will draw the curve, and oh yeah, this is curve. We have the y-axis or the vertical line, and we have horizontal line. The vertical line represents the temperature, and it's in degrees Celsius. The horizontal line represents the time, okay, in seconds. I want to give some numbers like 2, 3, 1, 2, 3, 4, 5, and let's say that we have some degrees in here. Let's take about like 10, 20, 30, 40, no problem. And we told you that we have a gas, and this gas is gonna be like liquid and then solid by cooling process. So if you start to cool a gas, okay, the temperature will start to decrease, and here we have a gas. When you decrease the temperature of a gas, the particles start to move slower and they start to lose energy, and they become closer to each other in this case. So they start to become like liquid. So in this case, we are decreasing the temperature of a gas, and this temperature of a gas will start like to become partially liquid and partially gas. So what if I ask you what is the state of matter in this area from A to B? It's a gas, and then from B to C it will be mixed between gas and liquid, so it will be gas and liquid. All right, and we didn't finish, we're still decreasing the temperature. Okay, so we're still decreasing the temperature. What will be here? The state of matter in C to D is liquid. This is liquid. All right, and what will happen after that? We will decrease the temperature of liquid until we reach to become solid. Okay, we have solid. All right, but before we got from liquid to solid, the process is called the freezing. And if I ask you to tell me about the state of matter from D to E, it will be liquid, solid. Okay, because you're turning the liquid to solid, then we are freezing that. If I ask you to tell me about the freezing point, okay, we didn't finish, we want to complete that, and we still decrease the temperature will become there. So in this area, the state of matter is from EF, the state of matter is completely solid. But if I ask you to tell me and determine the freezing point, first of all, you will look at the horizontal line, which is from D to E, and then you can draw a dotted line or horizontal line, and you can read the temperature from here. We can write, or let's say think about this approximately. It's about 15 degrees, because it's the middle between 20 and 10. So we can tell you that this is the freezing point. 15 is the freezing point of your material. Okay, if I ask you how long it took to form gas to liquid, what is the time that we needed to change your material from gas to liquid? You will say, like, when I change the gas to liquid, it means this is condensation process. So you will tell me, like, we draw the vertical line on the x-axis. So the process from minute 2 to minute 3, we can tell you that we are changing the material from gas to liquid, and actually it took only 1 minute to change to or let's say change from gas to liquid. Okay, from gas to liquid it took only 1 minute. So from B to C there is condensation process.